Okay, for our next example, I'm looking at it. It looks really exciting. Like I've been given a derivative and I'm supposed to go backwards and find the original function. And then I'm supposed to go forwards and find the second derivative. I'm actually going to treat these like two separate problems, okay? So I'm doing the red one first, and then I'll come in and do the green one. Now, the red one, I'm trying to do it exactly the way that I did up here, which is to say to make my f prime number line, check to see whether or not the function is positive or negative. So I see that the function is positive here, and I see that it is negative here. And so I want to say that exactly at -2, it looks like it's equal to 0. And so that's my possible critical number. And here I've got a positive, and here I've got a negative. And so if my slope is negative and then it goes positive, that is probably a minimum. Okay, but let's just see what's happening with the slopes themselves. And so if I have -2 in my mind, I mean, I'm saying all the way through this piece is a positive slope. So it's only actually here at 0 that I start to get worried, okay? So all of this section is a positive slope. Okay, it's positive at -2, it's positive at -3, it's positive all the way up to 0. And at 0, this is a problematic spot where I wouldn't want to take a derivative. And I might say that the derivative of this doesn't exist, but I'm not on the second derivative yet. So I'm still trying to go backwards. So I'm just saying that if I look, here, that's a positive slope. And here, that's also a positive slope. And here is a positive slope. And all the way through all of that, I get a positive slope, which means that it's basically concave up everywhere. Right? So if I have positive, 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 there's no point of inflection. And so I feel really good about saying that at -2, it should be concave up, and on the other side, it should also be concave up. Okay? Now, let's move on to the green. So looking at the green function, I'm going to erase all this. I want to be able to say exactly what the derivative is. And it turns out I feel really good about it because I actually know what the equation of this line is. And you should know what it is too, because I am going down 1 and over 1, right? So I'm saying this is whoops, my bad. I'm going up 1 and over 1. So the equation of this line is y equals, and it's a positive slope. So it's x, it's going up 1 over 1, and it has a y-intercept of 2. And so if I want to take the derivative of that, y prime would be 1, literally, just 1. And so here's 1, and all of that is my derivative of this first section right here, okay? Now, I'm putting an open circle here because, like I said, there's a cusp. And at that cusp, I don't think I can take the derivative. But I still can talk about, and I'd like to talk about, the equation of this line. And that line looks exactly like y equals x squared plus 2 to me. It's a parabola. It goes up 1 over 1. It should go up 3 and over 1 from there. And so that's my parabola. And I'm saying if I take the derivative of this, I should get 2x. And so if I want to graph 2x, technically remember that the constants are lost when you take derivatives. So this is plus 0, okay? And so I want to say, hey, I'm going to graph 2x, and that means up 2 and over 1, up 2 and over 1, and I only want to graph it on this side of the x-axis because this is the side that they graphed of that parabola. And there you go.